Hello, and welcome to today's webinar, How to Optimize Sales Analytics Using 10 Times the Data at 1/10 of the Cost. I'm Carol Gunst, Marketing Director at AtScale, and I'll be the moderator today. Before we get started, I want to mention that all attendants are in listen-only mode and that this webinar is being recorded. You will be sent the recorded version of this webinar within 24 hours. I also want to let you know that we'll be opening this up for Q&A. So please add your questions in the box at the bottom of the screen and we'll take them at the end of the presentation. So today we're going to learn how to perform sales analysis on billions of rows of data, add new dimensions and hierarchies for drill down analysis in seconds, build what-if analyses using 20 times faster using OLAP, analyze near real-time data for more accurate KPIs, and report consistent KPIs across BI tools. And now, let me introduce you to today's speakers. Matt Hartwig is Associate Director of Product at Wayfair. He's worked there for 5 years. Before Wayfair, he worked at Verifone and Curb in product management roles. He's a graduate of Dickinson, and he holds a data science specialization from Johns Hopkins. Dave Mariani is co-founder and chief strategy officer at AtScale. Prior to AtScale, Dave was VP of engineering at Clout and at Yahoo, where he built the world's largest multi-dimensional cube for BI on Hadoop. Dave is a big data visionary and a serial entrepreneur. And now, let me hand it over to Matt. Matt?
Thanks, Carol. Hello, everyone. So to get started, I wanted to give some background into where I'm coming from. So I work at a company called Wayfair. And ordinarily, if I didn't have a background, I would just be able to point behind me and say, look at all the stuff that's furnished behind me. And that's what Wayfair is, right? We're sort of one of the largest e-commerce sites specializing in home goods. And at this point in time, we're sort of the clear leader in that home goods space for online retail. But how we actually get that furniture into someone's home largely comes from a company that is backed by thousands of software engineers focused on building out proprietary technologies and also integrating sort of best in breed third-party technologies like AtScale, as well as cloud technologies from our preferred partner in GCP. Coupled with that is also investments in a specialized logistics network that starts all the way where products are actually manufactured, often in Asia. We have a container freight service where we actually bring those items over, inject it into our warehousing network. We forward position the products all throughout the country. And then when a customer goes onto Wayfair's website and they purchase an item, hopefully that item is located in a warehouse very close to them. It'll be delivered to them typically in a Wayfair truck if it's a large item like a couch. Sort of importantly, the company was founded by 2 Cornell graduates who are still sort of the primary shareholders of the company. Neeraj Shah is still the CEO of the company. And sort of all of this is driven in large part, and a lot of Wayfair's success is driven by how it uses data, right? And we actually track data on how Wayfair uses data, and we do reporting and analysis on the usage of data at Wayfair. So we know we have about 900 million interactions every single year related to data, right? And that could be someone in our supply chain going and running a query to figure out how many items are currently sitting at a certain warehouse, right, of a certain type. It could be an analyst going and trying to figure out why a certain item is getting lost in transit on a regular basis. It could be someone going in and looking at a report to just see what is Wayfair's current revenue, right, for the given day. And about 250 million of those are actually driven by people, which actually tells you there's a big divide between those interactions that are happening by people and happening by systems, right? Of those people, it's largely a combination of business analysts, BI developers, and data scientists. And Wayfair has hundreds of sort of each class of individuals. So we have hundreds of BI developers, we have hundreds of data scientists, and we have hundreds of analysts, right? And Wayfair's approach to sort of managing and serving all of these users has been to form a data infrastructure team, right? And that's where I belong, right? So I lead the product organization for many of sort of the subgroups within the data infrastructure organization, principally focused on all of our sort of analytics user persona. So data scientists, data analysts, business intelligence analysts, as well as how we focus on sort of exchanging data between applications and different systems. So if you work at Wayfair and you work with data, very likely you are working with a system or a technology that the data infrastructure team is responsible for providing, managing, and operating, right? And so that's a combination of application data stores, data movement technologies, and analytics and data science tools. And we're a company that's very oriented around building platforms, not sort of point product solutions. So a lot of our investment in the infrastructure group is setting up sort of foundational infrastructure componentry, building out abstractions on top of it that sort of act as a platform that people can then interact with, and then creating sort of integrated workflows on top of that, right? So it's not enough to make it really easy for someone to go and run a query, right? If we recognize that that's part of a workflow where they're going to start by sourcing data, then they want to run a query, then they want to enrich the data set, maybe by joining it to other things. And then finally, maybe they want to schedule that, right? We want to integrate those workflows and really make it efficient end to end. And sort of one of the concepts that I wanted to introduce to you all today is something that we talk a lot about at Wayfair, and something that I personally think a lot about and focus on in my day-to-day, which is this concept of velocity, right? And it's how Wayfair talks about speed and scale in everything that we do, right? So in design, development, decision-making, it's all about how we sustainably grow from the company we are today to a $50 billion company and to a $100 billion company, right? Because Wayfair's aspirations are not to sort of just maintain current market position and current success. It's to continue building on that. It's to continue growing over time. And so from an infrastructure point of view, and how we think about sort of serving our user community who are sort of often trying to analyze sales patterns, sort of seasonal trends, everything we're focused on is how do we make it so that we can do all of that more efficiently in the future, right? So when it comes to data, right, we think about that specifically as the speed with which Wayfair can go from data collection to driving business decisions, outcomes, and insights, right? So this is our concept of what do we mean when we talk about something like data velocity? We're trying to optimize this cycle time, right? So how quickly we can go from a data collection to some outcome that actually drives progress for the business, right? And I want to sort of illustrate that through an example. So let's say a customer is on our storefront, right? So they're on Wayfair and they go to one of our product pages. They look at the product and we see a lot of the sort of indications that they are high intent in market. They've clicked on things that suggest, hey, this person probably should buy, but they don't. They choose to sort of leave the website. They end up not purchasing the product, right? That generates a data point, right? Now 1,000 other customers come to this product page and we record all of the data for all of those interactions. And then 100,000 customers come and visit other pages with similar products. And all of that data comes together and is served to an analyst who's able to perform an analysis and identify, hey, we're seeing some lower conversion rate on our product pages after a recent deploy, right? So now we've gone from business collection through to an insight, but it's not business driving yet. We haven't actually solved the problem, right? So now we need to go and revert that deploy. And on the other side of it, maybe we roll back that recent deploy and we see the conversion rate recover to previous baselines. And so this is what we mean by a cycle time, right? We go from the data collection to the business insight to the outcome and decision that we need to make to new data being generated so that we can actually understand what was the effect of the actions that we're taking, right? And now data velocity is all about doing that at better and faster, sort of on repeat with just greater and greater organizational complexity, sprawl, and size, right? And so one way that you might approach this is you say, well, let's hire 1,000 more analysts, right? That's one approach that you could choose to scale. That's not the approach that Wayfair has chosen to scale, right? We choose to scale through platforms and technology, as opposed to through people and process, right? So we always choose to invest in either sort of best in breed technologies that we can find elsewhere, or we'll go and build it in-house to sort of optimize here. So in this case, maybe we'll actually optimize this not by hiring more and more analysts, but by introducing a machine learning algorithm, right? That can actually detect this and automatically communicate with another production application to revert that deploy and get us back into a healthy state, right? But when we think about sort of solving for data velocity at Wayfair, we face a lot of sort of typical problems that other large companies at a similar level of maturity face, right? So we have a fragmented tool space, right? The tools and technologies that worked for Wayfair when we were a $100 million company, when we were a $1 billion company, when we were a $5 billion company, are not the same tools and technologies that we need at our current state, and are certainly not going to be the same tools and technologies we need when we're a $50 billion company, right? So we're heavily reliant on SQL Server analysis services, for example, right? We're heavily reliant on sort of a large mix of technologies that are relatively fragmented and were never intended really to work together. We also have a fragmented identity and access management system, which is sort of further exacerbated by the fact that we have fragmentation in the tools, right? So if you have fragmentation in IAM and you have fragmentation in tools, that amplifies the impact, right? So employees are stuck in what I call ticket hell, where they need to put in a ticket to try and resolve some permission access. I need access to AtScale. Now you need to put in a ticket. We've actually solved this for AtScale, so it's not a good example, but I need access to this data set, you need to put in a ticket. I need access to this server, you need to put in a ticket. It's sort of a constant struggle that we faced over the past 2 years. We have really, really rapid data volume growth. This is actually, Wayfair is one of those fortunate companies where the global pandemic has actually accelerated our growth as a company, right? So data volumes today are 100% greater than they were at this time last year, right? And that leads to a lot of challenges, particularly if you're trying to manage on-premise infrastructure and you're trying to do capacity planning, which Wayfair for the longest time was sort of in the game of. We were trying to sort of forecast capacity. We would have gotten it really wrong in the case of the global pandemic. We also have data just sort of everywhere. Our existing data warehouse and data lake systems store hundreds of thousands of data sets. If you were to count the combination of tables, views, dashboards, machine learning models stored in sort of like pickle files, we've got over 1 million different of these assets, right? And many of these are actually just copies of one another, right? Because in some cases, we have systems that we couldn't actually scale vertically, so we had to actually splinter them and scale horizontally. So we've got multiple copies of identical data sets living on many different servers, right? Which means if you need to go and find data, source data for that project, let's refer back to that analyst who's trying to look at conversion rate. If they need to go and find the source for data for conversion rate, where do they go? How do they find that data? How do we translate going from I know that there's a question I want to answer to the data you need to answer it as fast as possible, and then long lead times. So scaling our on-premise infrastructure has always been painful, and sort of bringing all of these things together, we had sort of a very challenging situation. And largely, we've been focused on solving this, thinking through sort of 5 pillars of data velocity. So I'm actually going to start in the bottom layer, and I'll work left to right after that. So scalable infrastructure. So one of the sort of meaningful things that Wayfair has done is shifted from an on-prem only company to a hybrid model where we work heavily with Google Cloud Platform now. We're one of Google's larger clients. And we've actually shifted the majority of our data-related workloads into GCP, in part because they're rather bursty, right? So having elastic scalability is really, really important. And so that shift to GCP has been very meaningful because it's meant that we've been able to solve sort of the long lead times and the rapid data volume growth. Those really actually haven't been issues for Wayfair during the global pandemic. We also think data literacy is underrated and really critical, in part because of the thing that I'm going to get to on the top right of this shortly. But every employee at Wayfair needs to be an analyst, right? We don't want to hire a team of data analysts. We want to hire someone onto our operations team, and they're an analyst because they're on our operations team. We want to hire someone onto our marketing team, and they're an analyst, right? we sort of think of them as citizen data analysts, citizen data scientists. We want to make it so that everyone feels comfortable working with data and is capable of sort of making the next big insight for the company. Another area of sort of that is sort of very near and dear to my heart, this is a thing that I work on a lot, is how we exchange data at Wayfair, right? So many companies exchange data through replication or transactional change tracking or CDC replication. Wayfair is trying to evolve its approach here. We're shifting more towards a domain event model where sharing data is done very intentionally and is published by engineering teams that actually treat that data like a product, right? And this is very important to us because we've run into challenges with the reliability of data, with guarantees around data exchanges, with the actual meaning of data. When you've got a million different data sets, you might have 100 copies of data that all look slightly different. How do you know which is the right one? If there's a product person owning that data and intentionally making it available for use by others, they can help solve that problem. And then data curation and transformation, right? All of that data is flooding into a data lake, or could be flooding into sort of different data pools, depending on how you've organized and structured your environment. Almost always there needs to be additional sets of transformations done outside of what's coming from the engineering systems, in part because we want to optimize and make things more and more efficient to be used by our presentation layers. And this is actually an area where AtScale has made it a lot easier for us, right? AtScale builds intelligent aggregates, which I think they're going to talk about, which means that our engineers on our side, our data engineers, don't always need to think about what are the appropriate aggregate tables to put into place to optimize for a certain for read performance. And then the last thing on the far right is self-service tooling, and this has been a sort of a major transition for Wayfair. We've always been pretty good about offering self-service access to data, but self-service tooling has not been the case, right? We give people access to SQL and say, good luck. We've been investing a lot in the tools and technologies necessary to sort of enable people to go and curate, enrich their own data, build their own reporting, share their reporting with their peers. And so we actually dissolved our business intelligence team and turned it all into a team of data engineers. So those folks focus on the data curation and transformation, and just everyone at Wayfair now does self-service business intelligence reporting, right? And that is largely enabled. So I mentioned before that Wayfair builds a lot of proprietary technologies. We are not building our own proprietary self-service BI technologies, right? We are reliant and focused on expanding the use of AtScale. So we were a historical SQL Server analysis services user. We had query volumes about 300,000 every single month. We had many thousands of users every single month. And this chart on the top left is one of my favorite charts because it shows the decline of SSAS usage next to the increase in AtScale server usage, right? And so that October one, I actually took this screenshot a little bit earlier. In October, we're actually on track to hit something like 350,000 queries with AtScale. And on the right-hand side, you can actually see one of the ways that we look at sort of when we have these legacy systems and we're introducing new modern systems, we don't often sort of put mandates in place and say, thou must now use the new modern system. What we do is we say, hey, the modern system we expect to be better. And because it's better, we expect people are going to choose to go and use it, right? Because data is so important to their jobs. They're always going to choose to use the thing that actually helps them do their jobs. And so we like to look at that shift over time. And so in some cases, you can see there's this intersection period where people are using both AtScale and SSAS, right? And that over time is being cannibalized by just purely AtScale. Largely, that was just driven by data gaps in our AtScale cubes. We had more data originally in our SSAS cubes. We're pretty quickly closing them. And AtScale has sort of been a facilitator both for our cloud transition, right? We run it off of Google BigQuery. So it's helped move people to Google BigQuery off of things like SQL Server, where we want to sort of de-invest strategically from an infrastructure point of view. And it also has had the benefit of sort of opening up broad access to data because we can put AtScale behind something like Tableau, right? Or we can put it behind Excel, and people now have the ability to go and access a single data set and go and take advantage of it. And so at this point, I am going to pass it over to Dave, who is going to tell you a lot more about AtScale.
Thanks, Matt. That's amazing. Wayfair in general has just like been one of my favorite customers, because you guys are data is, you live and breathe data, and you use that to differentiate your services and your products and your company compared to others. And it's proven to be really successful, obviously. I have a lot of Wayfair furniture in my house, so it's definitely working. I think I'm gonna switch over and tell you a little bit about AtScale, but really try to show you a little bit about what the people at Wayfair are doing with tools like Excel directly against AtScale on Google BigQuery. But I think we're gonna run a very quick panel, or a quick survey. So Laurel, why don't you go ahead and do that? Okay, so this is a quick poll just to see what you guys think of the audience here. So which of the following do you see as your key challenge to optimizing analytics and data velocity? So we'll give you about 20 seconds to come up with your answers there, and we'll show you the results. Darn, I can't vote. You can't vote either, Matt. I know what your answers might be. And the answers are, let's see. So data duplication, wow, and fragmented tool space, and rapid growth of data. So those are sort of the three top ones. So obviously data duplication is on everybody's minds these days, and making lots of copies, of course, just creates more pressure on these other problems that you see here, as Matt mentioned. Okay, so let me share my screen, and let's pick up where Matt left off here. And what I'm going to do today is talk a little bit here about how to optimize your business, and in particular sales analytics with big data. So just a little bit about AtScale in case you don't know what AtScale does. Well, AtScale fits in the middle of your modern cloud stack. In the case of Wayfair, Wayfair is a GCP or Google Cloud customer. So their data is all being loaded into files just on the Google Cloud. They're then loading a Google BigQuery, which is their data warehouse. And AtScale then sits on top of that Google BigQuery data warehouse to issue its queries. So AtScale is a semantic layer, and it's a virtualization layer. And what that means is that you don't load AtScale. We don't load, we have what we call virtual cubes, and the keyword being virtual, because we actually don't physically move data or load data into AtScale. Any query that AtScale is going to generate is going to be to generate directly against the warehouse or the data store that we're talking to. In the case of Wayfair, that would be Google BigQuery. So AtScale does that by creating aggregates, and it actually does that by actually exposing a multidimensional engine to the tools that are consuming it. Matt talked about Excel and Tableau. Of course, there's Power BI and a host of other BI tools, including data science notebooks, as well as custom applications that all can take advantage of this same data governance and virtualization engine. So what that means is, regardless of how you consume the data, you're going to be dealing with the same view of that data, and you're going to get the same performance with the same governance and security rules, regardless of which application or tool you're using to consume that data. So today, I'm going to be primarily using Excel. And what I was going to try to do is it's going to be a silly little example, but I hope that it will make the point, and you'll see the gist here. But we're going to create a model, and we're going to try to forecast inventory, and we're going to try to forecast sales, actually. And we're going to do that for 2020. Q4 using SafeGraph's foot traffic data. So SafeGraph is a company that actually, for the retailers that that allow it to, are actually tracking phone data to be able to count people who are visiting stores, and so they make that data available in a data exchange, and I'm going to be using that data to compare COVID versus pre-COVID, so 2020 versus 2019. So so let's go ahead and let's go in the first step into sort of creating a Excel model to actually predict sales for Q4 for the holiday season. And I'm going to predict those sales, and I'm going to adjust those sales based on my foot traffic data. So I first have to obviously load my foot traffic data as well as my sales history from Q4 of last year if I have a chance to do this. So let's go and see how that would work. So I'm going to go to, let's go to my browser here. Okay, so what you're seeing here on the screen is actually SafeGraph's website. And in SafeGraph's website, they have several different types of data available. I'm going to be using today, for today's demo, I'm going to be using the weekly places demo. And if I click on this link, and you can see here that there's a number of different sort of files that they allow you to download. And I'm going to go ahead and then go ahead and click that generate links. What it's doing is actually preparing the data for download. Well, as that does that, let me go to my downloads folder here and show you a little bit about what this data is going to look like. So here is my weekly patterns data. You can see that the weekly patterns data itself is actually compressed, and it's actually over a gigabyte. And even sort of the next best, the summary, let's just go ahead and look at that. And let's look at that with my Excel and see what that summary data looks like. And this is, this is a roll up basically of that weekly data. I actually need that granular data, but let's just go ahead and see what it looks like in Excel first. So you can see there's a census block and a number of devices. So again, this is all anonymized, so it's not too creepy, but it is looking at devices that come into their Wi-Fi. And if I just go to the very bottom here, you can see that I'm already dealing with a lot of rows, even with the summary data. And that doesn't give me location, because I'm going to be showing you today a demo with a sporting goods store. And so I need to know what my cohorts are in the sporting goods industry. It's a brick and mortar for me to be able to better predict what the impact of foot traffic and COVID, the impact of COVID on foot traffic in sporting goods stores, because that's very different than, let's say, some other retail shop or restaurant and food and beverage. But you can see that there's already 220,000 rows. Well, I know for a fact that Excel taps out at 1 million rows. So even the summary data is already going to be really challenging if I actually want to deal with this and use a tool like Excel to actually manage and massage that data. So I'm not going to do that. Luckily, there are Snowflake today. I'm going to be running against Snowflake for my demo today, because actually Snowflake actually has a marketplace, and you can, it's actually for free. And you can see here, I could have my foot traffic data, my core places, and I can just go ahead and click on those, and I can get access to those tables. So what Snowflake will then do is it will show me my weekly patterns data, and it'll show me that in a shared table like you see here, right in my own space. So you can see that the weekly patterns data, it's actually 351 million rows of data. That's pretty big. It's definitely too big for Excel. So I'm glad I have a data warehouse to back it. Google BigQuery and the Google Cloud also has shareable data sets there as well. So you can do the same thing there. And you can see that it's very big once it's all been expanded and loaded for all time. So if I look at that data, so this is actually a preview of that SafeGraph weekly patterns data. you can see what I got here. And something that I just want to notice is that you can see that, to compress it and to get it down to 351 million rows, it's actually using nested data. So you can see the visits by day is encoded here, as well as my visits, as well as my the different locations and locales here. So to be able to use this data and to use it to forecast my sales, I got a lot of work to do here. I'm going to have to do a lot of ETL to be able to split this out and make some sense out of it. Because first of all, it's weekly, and I need to look at it, compared it year over year. And then I have to explode out these data fields. And if I'm doing it, I guarantee you that my partner next to me is going to do it a little bit differently and is going to get a different answer as a result. So that's not very fast. And that's not, as Matt said, that's not really great when it comes to velocity and agility. So what can I do instead? Well, what I'm going to do instead is that I'm here in AtScale Design Center. And Design Center, what we're going to do is that we're going to create a new virtual cube, and we're going to call it, I don't know, Safe Graph foot traffic. And I'm going to go ahead and add a new virtual cube. And then what I'm going to do is that I'm going to go ahead and enter into my model. So with this project, so I already have my third-party data project. I actually can use our AtScale library. And so I can, for example, look for my Safe Graph visits by day, which is what I want. I can pull it onto my canvas. And now I have access to that data in Snowflake. So let's just go ahead and take a look at what that data set looks like. Well, you can see that I have actually a query here that's actually running against the sales, the weekly sales pattern data that's in Snowflake. And if you notice what I have here is that I actually am flattening that data. So I'm using the Snowflake function that actually will take those nested fields and flatten them out. And that gives me something that's really nicely workable. So the next thing I'm going to do is that obviously I'm going to want to look at this data by date. And for that, I'm going to stick into my library, and I notice that I have a date dimension. So here's my date dimension, which has a couple hierarchies. It has a monthly hierarchy and a weekly hierarchy. To be able to use this date dimension, all I need to do is to hook it up or create a relationship. So I have my visit date here, and all I need to do is drop it onto that dimension, and then look what's happened over here on the right. This is what you're going to see in Excel today. You can see I have all my different data attributes, and then look, I have now my two hierarchies. I have my month hierarchy, and I have my week hierarchy. That all came for free just by dropping onto this conformed date dimension. So we haven't gotten rid of OLAP here, right? OLAP is really powerful when it comes to having dimensions and standardization and making things really easy to consume by a user to promote this kind of self-service that Matt was talking about. So what else can I do? Well, you know what? I also want to let's look at some more safe graph location. So you're going to see in my demo today that where the foot traffic is happening is important, because remember, I want to look at my cohorts in sporting goods. Well, you can see I have my Safe Graph place ID, and all I need to do to hook that up is to do that. And what did I get now? You can see that I'll just collapse my date dimensions. I now have my NAI CS codes, and I have my hierarchies there. So you can see I have sector and subsector, as well as I have my locations. And we're going to be using that location shortly in our demo. So I can go ahead and continue to build out this model. You can see I already have some rich model, but I don't have any measures yet. It's all the same process of drag and drop. So then all I need to do, of course, is to publish this, and that cube and that virtual cube is now live. So what does that look like? you can see that this is the third-party data with the safe graph data virtual cube, and you can see that it is quite a model. And at the same time, if I look at my sales insights data, I have a second cube, which is my internet sales data. So I'm going to also be blending two different virtual cubes today, because remember, I need to get my last year's sales for 2019 Q4, and I'm going to get that from this virtual cube. And I didn't have to do, all this modeling, and all these relationships are all done in AtScale, done once, and done for all those self-service consumers. So all those consumers in Wayfair are dealing with data that's clean, that's correct, and it's usable for self-service. So so then what did we really, really learn here? Let's go back to my presentation here and talk a little bit about that velocity and agility. Well, we know that data integration is slow and cumbersome, and it's really the opposite of agility and velocity. So what I just showed you today, and I'm going to show you how we now use it, is how we leverage data virtualization to access that data quickly and easily without having to do a bunch of work. So while there still is data transformation and ETL work that you may want to do to clean up your data, you don't have to actually create reporting structures. Matt talked about creating aggregates or even creating star schemas to support analytics. AtScale can do all that virtually for you. Now you can, if you like, you can go ahead and build data pipelines like I did at Yahoo using Hive, where I produced 2,500 aggregates every day. And I had to then load them into Oracle and then load them into MicroStrategy. So lots of data movement, lots of chances for data copies, which you guys all said that you don't like. I could also use ETL tools like Informatica or Talend or Matillion, which is more like ELT tools to move data around. But I think that that's a lot of work. I think you can use a data virtualization to get there much faster with a lot less friction. Okay, so what's my next step? My next step is let's go ahead and do the actual work, and let's create the Excel model to forecast my sales. So I'm going to go into my my Excel environment here, and the first thing I'm going to do is I'm starting with this a plain old a straight Excel spreadsheet here, and I'm going to go to my data tab, and I'm going to start to get some data. Now, the way you can do this with AtScale is that AtScale looks just like analysis services. It's a big reason why Wayfair chose AtScale is they had a big investment, as you saw in Matt's slides, in analysis services. So they didn't want to have all their users be retrained and retooled to be able to move to GCP. Instead, you can go ahead and use the built-in analysis services connectors within Excel. And what I can do is by talking to the AtScale service, you can see I can now connect to my third-party data project, and there's my safe graph virtual cube. So now what I get is I'm going to actually build a pivot table right here in this sheet. So let's go do that now. And you can see there's all my safe graph data that you saw in the AtScale virtual cube design center model. So I can simply go ahead and say, for example, I definitely want to see what my daily visits are. So by clicking that actually runs a live query against AtScale, which is then run through Snowflake. Now in Wayfair's case, of course, that would be BigQuery instead. So that gives me my total visits, but that's all fine and dandy, except that that's visits for everything. And it's visits for everything for all time. So the first thing I want to do is I obviously don't want to have it to be for all time. So let's go and find my date dimension here, and let's filter this down. So let's take my date dimension, which is here, and let's choose my my date hierarchy. So I'm just going to click that there. So now you see I have my pivot, and it shows me all the years which I have safe graph data. I'm going to go ahead and click on this and filter that down just to, let's see, I want last year's. So let's look at last year's foot traffic, and I'll do that. So now I'd have just 2019's foot traffic. There was 13 million entries there. Actually, no, sorry, 13 billion. What am I saying? That's a lot of foots, a lot of feet. Okay, so let's now go to, that's for last year, that's good, except that, remember I talked about our cohorts? I'm a sporting goods store, and a brick and mortar one at that. So I'm gonna go back and use my SafeGraph data that for location. Remember when I dropped that location onto my sheet? So I'm gonna go ahead and use that now as a filter by dragging it into the filter. So now you can see the SafeGraph location, and if I click on that, I can now do a search for a cohort. I'm going to choose in California, we have Big Five sporting goods. So I'm going to do Big Five and do a search on that. And there's my Big Five sporting goods. So I'm going to choose that. So now what I got is I got just the foot traffic for 2019 for Big Five. So obviously I want to see what it is this year, because this year with COVID, a lot of stuff has changed. So what's cool with pivot tables, oops, I have to do Control C, is that I can copy them and I can paste them. And there we go, I got a new pivot table. And now all I need to do here is just change my date from 2019 to 2020. And voila, what I got now is I got my 2020 years. Now what I can do is I got my difference here. Now all I need to do to build my model is to get my sales data. Well, for that, my sales data is in another virtual cube. So I'm going to go back to my data well here, and I'm going to go and click on Analysis Services again, and use my credentials. Of course, these credentials are not going to be admin, it's going to be whoever you are. And here's my sales insights, which is my sales data. And I'm going to go ahead and get that. So what I'm going to do there is I'm going to go ahead and create another pivot table. And this time I'm going to choose my sales metrics. I'm going to choose my sales amounts. And then of course, I don't want them for all time. I only want my sales amounts for last year. So I'm going to go to my order date dimension, and I'm going to choose my order date by month and click on that. That's going to give me all my time. I'm going to go ahead and filter that down from just to 2019 in Q4. So I'm going to go ahead and open that up and choose just Q4 of last year. And so now I only have my data from Q4 of last year. So now let's predict my sales. Again, I said it's a silly model, but forgive me for that. So the first thing I'm going to want to do is, well, let's go and let's calculate my foot traffic delta. So I'm going to do that, and I'm going to do that by saying, for example, I'm going to say it is going to be this year minus last year. And I'm going to go ahead and make sure I got my parentheses right. And then I'm going to divide it by last year. And I'm going to get a percentage. And there's my percentage. So you can see foot traffic has actually dropped by almost 40% this year versus last year for Big Five sporting goods. That's pretty dramatic. Okay, so now I can just simply predict my sales. So projected, let's call it projected 2020 Q4 sales. Now I can just take that foot traffic drop. I can say, for example, take my my sales and then multiply that times my formula times my percent, and voila, there's my projected sales, and I'll put it in dollar terms, and there's my projected sales for this year. So instead of 6 million, I'm going to get 3.8 million. So you can see there, there's something that's interesting there, right? First of all, this data is now all live, and now I can refresh this and get new data at any point in time. So it's not a copy and a paste. This is live data. To show you that, watch what happens if I just reference this cell. You see how it created a formula here? Now that cell, you could see, is now a coordinate that's pointed directly to a cube. That is really huge, because that means now that I didn't have to actually create a pivot table. So you can see it's using the pivot get pivot data. I can also use cube value, which is a really important function. So I can then sprinkle these coordinates in with my own calculations and my own data in Excel. And when I refresh this workbook, it will automatically fetch those cells from the AtScale virtual cube, and voila, your data is up to date. That's super powerful. So, that's for 2019. And of course, here's 2020. And you can see there's the difference. 2009, there's 2020, there's 2019. Level and unfold it. That is, just lost my share. That is not easy to do. So, so what we want to do is really leverage, if you can, leverage OLAP and MDX calculations. And I'm going to show you something to do even better, and compute those kinds of metrics server side. The alternative instead is you can use Excel and compute those kinds of calculations within Excel. The problem with that, of course, is that when you go to update that data, you're going to have to actually manually integrate data into those cells. You're going to have to keep straight what data comes from the data warehouse versus what data is the calculations or data that you computed. You can also use some pretty advanced SQL functions and try to calculate those metrics yourself. But again, it's more going to be more engineering, and more time, and obviously a lot more room for error. So then let's go and talk about refreshing this forecast. So that's our step 3. So let's say now we want to roll forward. We're done with Q4. Hopefully it's a decent holiday season, and now we want to predict sales for Q1 of next year. So how are we going to refresh that model? Well, let's now go back to my Excel environment, and I'm going to rename this good, because that's okay. So I can go ahead and refresh this just fine, but I think that we can do much better. And let me show you what I mean by that. So let's go back to Design Center for a second, and let's look at my third-party data cube, and let's look at a calculation. What we did here is we actually created a calculation in MDX. So what I could have done, instead of manually creating those 2 pivot tables and then coming up with what the change was for this quarter this year versus this quarter last year, I could have just done a relative formula using MDX that did that for me server side. So also, if I go back to my sales cube, and I did this, I could do the same thing in my sales cube. So for my sales and my sales for this year, what I can do is, or last period last year, again, I can use an MDX function. And you can see that there's this keyword called parallel period. That's super powerful, because that means that this formula, sales amount for last year, is going to work regardless of how I use it in whatever context. So now let's go and use those for real. So I'm going to go back to let's go back to my data here. This time I'm already connected, so I don't have to worry about reconnecting. I'm going to use my existing connections. And let's see, let's start with let's start with our sales amount. So let's start with our sales for this year. So instead of doing all those clicks that I chose before, I can make this even easier because I can just go to sales amount and I can just click on that metric, and voila, now I have my sales amount from from that quarter last year. So look at that, that's 6.3 million. And there's my 6.3 million. So instead of even doing all those clicks, I made it a one-click type of function that was all done server side in AtScale without users even having to do it. Now I can also do, let's go back and let's do the same thing with my SafeGraph data. So let's choose my SafeGraph connection, and then let's go and just choose that relative function in my SafeGraph, and it's prior period relative. Let's get that, and then you can notice it's 42%. But wait a minute, it's like it's 42%. Why is it 42% and not 39%? Because I haven't filtered it yet. So that is the amount of change in foot traffic for all industries was 42%. But of course, I want to be able to choose my cohort. So I'm still going to go back and choose my, let's see, where is it? My location here. And go ahead and change that to Big Five. Sports, and there we go. And if I did everything right, of course it's 39%. There you go, 39.55. So again, I don't need to do a pivot table for that. I could have just done it as a straight cell using a cube value function, and I'm going to get the same thing as a coordinate, and you can see it right here. So you can do crazy stuff. The Wayfair team has done crazy stuff with Excel and of course Tableau with AtScale. And you can see that you can create some very sophisticated models, and refreshing them is simply a matter of going to the analysis tab here and saying refresh and refresh all, and that's going to refresh every single cell and say keep all your formulas intact. And you can't do this, by the way. You can see how fast that just refreshed. Let's go back and see what it actually did in our query log screen in AtScale. Well, you can see it just ran all these queries, and look how fast it ran them. It ran them in a fraction of a second. And you can see that it ran an MDX statement, which is pretty complicated. So that all came from my spreadsheet that I just refreshed just now. You can't do this if you're just running against Snowflake or BigQuery by itself, because it just can't run fast enough. That ran in 327 milliseconds. And to do especially complicated models, you can't expect queries to run for seconds. Even seconds is too long to make this work and to be really scalable. So then what did we actually learn here? And let's just bring it all home, and we'll open it up for questions. So what we learned here is that if you leverage direct connections to data, you leverage server-side types of calculations, you're gonna increase that velocity, and you're gonna increase your agility and allow for that self-service that you want so bad, that Matt and the team at Wayfair have done so great, so nicely. And you can of course update that data manually. You can build that logic and all that data prep into a custom application. All that is not agile, all that is hard, and all that is going to take a long time to get data into the hands of the people who need it the most. So I encourage you to go to our website, and we've done some benchmarks on 10 terabytes of data against all the different data platforms, against BigQuery, and of course Snowflake, etc. And what you can see here, and a big reason why companies like Wayfair and other BigQuery customers of ours have chosen AtScale, is that it's much less expensive, 10 times less expensive, and we're going to give you much better performance on a really great asset and a really great cloud and a really great product, we're going to make it better. So, so to bring it all home, use virtualization and deliver faster time to insight. You can use OLAP and tools like OLAP with Excel. Define those calculations server side to have a single source of truth. You can have live direct connections to data, so you're not dealing with sneakernet and manual copy and paste to create models, which is the reason why IT hates Excel so much. We've made Excel really compatible and easy, but also secure and correct, because we're not copying data around. And of course, just like Matt said, you got to build it upon a scalable infrastructure. So by moving from on-prem to the cloud on GCP, Matt has and Wayfair has allowed the organization to scale with COVID, and to be able to do things and have hundreds or even thousands of analysts do the work and be a data-driven organization. So with that, Carol, I'm going to hand it back to you.
Thank you, Dave. I've got a question for Matt. Could you explain a little bit about how AtScale helped Wayfair with your migration from an on-premise environment to Google?
Yeah, so Dave mentioned this in one of his demos, but Wayfair has a lot of users working with Excel today, largely, well, not today, but 6 months ago, 12 months ago, we had a lot of folks using Excel and accessing data through SQL Server analysis services cubes. And at that point in time, shifting from SSAS, which was an on-premise technology that sort of was struggling to scale to the data volumes that we were working with, and really just even when it had data volumes that sort of were within its ability to process, like the performance just wasn't what we wanted. But in order to get off of SSAS, we really needed to do two things. One, we needed to shift our data processing for that underlying OLAP model off of on-premise systems into the cloud. And the second thing we needed to do was update how people were actually working with that data, right? So we thought it would be easier to update how we actually processed and served data through cloud technologies than it would be to retrain thousands of people using Excel. So the critical thing for us with AtScale was that AtScale would work with Excel. So it would seem like an SSAS cube to a user. It would just be faster, give them access to larger data sets, give them access to sort of more real-time data sets. And actually AtScale was the very first thing that we used to shift data-related workloads from on-premise systems to cloud systems. Now we're doing a lot more than just AtScale stuff in GCP as it relates to data, but AtScale was the very first thing that we used, and honestly, it was sort of our pioneering technology, in part because it just made it really easy. Like, we didn't have to retrain thousands of analysts. They got to sort of use the skills that they already had with Excel or Tableau, and now they were just working with a different data set. So instead, we had to retrain a much smaller population of data engineers who had previously been working with SQL Server analysis services. They were all really excited. Working with cloud technologies is a much better job prospects in today's market. So everyone was really excited that they were getting to sort of work with new modern technologies. So we took that much smaller population, retrained that workforce, and they've sort of been the folks that have spearheaded this shift.
Thanks, Matt. Dave, I think we've got time for about one more question today. Maybe you can answer, can you integrate with an AI or ML engine to get forecasts directly for use?
Yeah, that's a great question. So, AtScale has multiple interfaces. So to access our engine and to integrate other types of data. So either through JDBC, ODBC, XMLA, or through a Python library that we have. So we actually have a really good sort of demo that we can show where using Databricks or Spark You can generate new features and new predictions, and you can automatically add those new predictions and features to the virtual cube, which then allows them to be consumed by the analyst in their respective BI tools, whether that's Excel, Power BI, Tableau, et cetera. So, so absolutely, we don't, we're not doing predictions. We're making data fast, and we're creating aggregates, and that's where our AI and ML go into. But when it comes to being able to support the predictions, other than I did in Excel, sophisticated ML like predictions, we absolutely integrate really well with Jupyter notebooks through Python libraries, so that you can insert those predictions right back into those virtual models and publish them to everybody who needs them, not just data scientists, but also any knowledge worker who wants to verify and actually use those predictions to make decisions in the company.
Thanks, Dave. Well, thank you so much, Matt and Dave, for your time today and all the time you put into your presentations and demos. We really appreciate it. And thank you to Laurel for running our webinar today. Most of all, thanks to our audience for joining us today. That's all we have. I'm going to wrap it up now. So any other questions, please send them to info@atscale.com. Thank you. Bye-bye.